Hello everyone, welcome back to term 3. Today we're gonna start the chapter 13, probability and also the probability distributions. And so we actually did some questions in year 11, but that's why we can start doing some recapping things. And then start with 13A first today, simple space probability. So first one, we need to know what's the sample space and events. So random experiments, for example, we rolling a dice, and the sixth die will be the random experiment. And also these possible, like all the possible outcomes, we call the sample space, and we need to list all the sample space here. And this is how you're gonna do with sample space and events. So like that, for example, use the capital letters A for my even number, and then so even number will be 2, 4, 6. If A and B two events are union of these two, so we call A union B. So both occurrent. And if even A is like even number and 6 dice and the 6 size die, and then even B is the greater than 2, so those two is A is that B is those simple space, and we actually can say if A to B will be 2 to 6. And also we call something is called intersection. We're using the upside down with union 1. So we can say 4 and 6 in the middle will be your intersection. So this is all with like basic knowledge before we did. Now what we do is we're gonna try to have a look at the example A. For the simple space, what we do is we actually try to finish some question like that. So we say, if we got some tree diagram to help, like this, if you still remember how to create a tree diagram, that will be help you to understand the kind of question. So simple space 3 coins toss the result nodes. Okay, so first row, so we say first, and we say second, and we say third, and also the outcomes. All right, so first we have heads and tail, and we're going to, sorry, we should move these tails a little bit further. So now we have heads and tail again, and then we keep going. So we had heads and tail again. So it's basically how the moving like that way always. So we do heads and tail, and we keep going heads and tail and heads and tail. So that's it. This is like tree diagram. So because we only have 2 outcomes every single time you toss the coin. So the total outcome will be H, 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 T, and H, T, H, and H, T, T. And we're going to the second half will be T, H, H, and T, H, T, and T, T, H, and T, T, T. So we have 1, 2, 3, 4, 5, 6, 7, 8 outcomes. So then later on, and you have to write like that way, equal to, that's 8 outcomes in here. Okay. All right. Now we're going to do some determine the probability with equally likely outcomes. So equally likely outcomes, like outcomes only, like for example, if you toss the 6 dice as you're rolling the 6 dice, every single outcome is going to be 1/6. So that's the equally likely like that. So the probability for the equally likely outcomes, we're using the ratio. We're using the ratio, which is your total outcomes and what's your initial for the elements. Every single probability will greater than or equal to 0, and also in total outcomes will be 1, and the sum of probably all outcomes is 1. So adding all together, and if you don't have any empty sets, it will be 0. So if you not equal to A, that'll be 1 minus the probability of A. And this is a addition rule I want you guys to copy into your Bell reference, please. Yeah. So probability A plus probability B minus probability A intersection B. So that's equal to probability A union B. Yeah. And we call this no outcomes in common, so cannot occur together. We call them manually exclusive. So for example, we don't have any intersection, so which is manually exclusive. So now if we have a card, one card choosing the random will shuffle the deck, and then which is 52 cards. And if you're choosing the ace, so 4 ace in total, so which is, we say, probability of A equal to 4/52, that equal to 1/13. And B, not hard, so which is every single card is 13 hearts. So we know 52 minus 13. So not a hard will be 1 minus the probability of not hard. So what we do is probability of H equal to 13/52, which is 1/4, because you have 4 different colors, and now we'll do 1 minus 1/4 equal to 3/4, so 1/4. So that's not hard, which is P probability of H dash. That's not derivative, okay? Just be aware. And ace or a hard. This one, remember, that means you are probability of ace or a hard. So which is equal to probability of A plus probability of H and minus probability of A intersection H. So that equal to 1/13 plus 1/4 minus 1/52. Calculate this one, and so we can say use the CAS calculator, and then we can find 4/13, I think. Question D. So either a king or an ace. So we let probability of K first. So probability of K that equal to 1/13. Because it's either, so that means probability of K. So probability of K union A. So either K or ace. So which is plus probability of A that equal to 1/13 plus 1/13 equal to 2/13. Yep. Not too bad. And we're going to another kind of examples, which is we're using tables now. So now what we do is we have 500 people in total. A person, a regular, use the social media. So regular use the social media. So probability of yes will be 3/5. because we're using total. And question B, less than 25 years age. So people are less than 25 years, 24. So we say using that probability of age less than 25 equal to 240 over 500 equal to 12 over 25. Yep. And probability of C. So less than 25 of age and that's not regular using, okay. Less than 25 and not using the social media, which is the 40 over here. So probably not using an intersection less than 25. So that equal to 40 over 500, that equal to 2 over 25. Yeah, so not too bad at all. And now I'm gonna ask you guys to understand what is what is the probability of data. So we say number of events a curve to the divided by number of strokes. So what does that mean? So this is the frequency of the probability of the A. So in the question here, so you had a large number of outcomes. So 1,000 times following outcomes. And so first question they're asking, use the information to estimate the probability of observing 6 when the die is rolling. So the total is 1,000. So probability of 6 will be 97 over 1,000. So that equal to 0.097. So use the decimals. Or we can say 9.7%. So that's pretty much. And what outcomes would you predict the most likely the next time the die rolling? So you can say they reach the largest number, so 3. So 3 will be most likely rolled in next time. Yeah, so I like probability because I feel like this kind of relate to our real life. So hopefully that all makes sense. And then we can jump on to the next chapter in next videos. Okay, see you guys next time.